In this next video, we're going to look at the image of a parametric curve under a complex mapping. And the parametric curve we're going to look at is the line segment, so I'll call C the curve. It's the line segment from 1 to I. Now, there's always what's called the straight line path. And so to parameterize this curve, what we're going to do is we're going to take Z of t to be our start point, which is 1 times 1 minus t, plus our end point, which is I times t. And this is a parameterization from on the interval 0 to 1. Now we can check that this works by plugging in, well, first of all, it's linear. There's no quadratic functions of t, so it's going to give us a line. Then we can plug in 0. When we plug in 0, we get 1, as you'll see. And when we plug in 1, this portion becomes 0, and we get I. And your book has parameterization of the formula for the parameterizations of line segments, rays, and circles, and they're all good to know. So that's the curve we're going to look at. This is our C, and here's its parameterization. Now the function, the complex mapping for this example, is going to be the function which multiplies by I then conjugates. So W is IZ bar. And if you take a moment and think about what that is, it's a composite of two functions. It's the multiply by I function and then the conjugate function. Now multiplication by I is rotation by 90 degrees counterclockwise, and conjugation is reflection in the real axis. So from that information and just some basic understanding of transformation geometry, you can figure out what happens to this line segment. In particular, the line segment from 1 to I looks like that, parameterized that way. It's going to first get rotated by 90 degrees, and then it's going to get reflected. So this is the end, this is the image. But we want to have some practice with computing the image of parametric curves under complex mapping. So we're going to do exactly that. So W, the curve as a function of W, this is like f of z if we want, is going to be do f to z of t. Okay, so stick every point of our line segment into this complex mapping up here. And so we're going to look at I, z of t bar. And so that's first multiply by I. That bar was extra big. Let's make it smaller. And then bar that. Okay, so that's going to be I minus IT. Well, I guess we'll just leave it as I times 1 minus t, actually. And then we're going to get a I squared, so that'll give us a negative t. And then we bar it. And so that's going to be negate the I part, so that's negative I 1 minus t minus t. Or if we want to put the real part first, which I do, negative t minus I times 1 minus t, 0, and this is still the same time interval, 0 less than or equal to t less than or equal to 1. Now, when t is 0, we get 0 minus I times 1 minus 0, so that's minus I. So you start down here at negative I. And when t is 1, we get negative 1 minus I times 0 is negative 1. So you end over here, and you take the straight line path, because our real and imaginary parts are linear functions of t, and that's it. So let's just wrap up this example. The image of z of t under IZ bar is the line segment from negative I to negative 1.